So I think when we talk about game theory, one natural thing to think about is the Hunger Games. So that's why I put a question. So this question again, when I put a part of the movie as a question, I always change the payoff. So if you have seen the movie, don't assume the game is the same as the one the movie has. So the thing that I modify is still the main idea is the same. So we have 12 districts, so we have 24 people going into the game. They try to kill each other. Everyone wants to win. Everyone hates to die. So one thing I added is if no one decides to fight, then there's no game, which I think kind of makes sense as well. So the other thing that I added is I have a ranking of these people. So say 20, let's start with 20, 20, 21, 22, 23, 24. Even write this. So suppose they have a ranking. So the person with the largest index is the best. Basically, this is the strongest person, and this is the weakest person. I don't actually want to say names. So, anyways, so in my question, there was a sentence that says if a subgroup of people decide to fight, it doesn't mean that we are dividing people into groups. So that's not the game that we are doing. That game, the group thing is related to cooperative game theory. It's very hard, so we are not doing that. I'm just saying that if say these people choose to fight, so if all of them choose to fight, then these people form a group, and this group of people is a subgroup. If they decide to fight, then the person who's the strongest within this group, which is this person here, this person will kill them because he's the strongest, and he will kill everyone else as well. So basically, if a subgroup decide to fight, then the person with the largest index will win and everyone else dies. So that's what I mean by that subgroup thing. So going back to the problem, so I started by assuming when I have the summary statistics, I thought if we have just the number of other people who are fighting is enough. It turns out it's not. So this question is actually harder than I expected, but it's still solvable, obviously. So this is the person. I need to define two things now. So I need to define the number of people who choose to fight, who has a smaller index. Let's use n to represent the one with a larger index, and m minus I to represent the number of players who choose to fight, who has a smaller index. So what these two numbers means is this number means how many people are fighting who are weaker than me. This is how many people who are fighting who are stronger than me. So to think intuitively, we need the best response function given these two summary statistics. So it's either fight or no fight. So when it is optimal to not fight, so there are two situations. First, there's someone who is stronger than me who is fighting. Right? So if n minus I is larger, it means someone who is stronger than me who is fighting. I got killed anyway, so I don't care. So n is the best response. So that's the first case. Or the second case is when do I not fight? Is everyone else is not fighting. So this is equal to this is equal to 0. So that's how I get the conditions. So and then we think about the other one. So when should I fight? So again, if someone who is better than who is stronger than I am is fighting, I can fight as well because whether I fight or not fight, I get killed anyways. So I may as well fight. So that's the one case, and the other case is when there is any. So when there's no one who is stronger that's fighting, but when there is someone who is, this should be equal, sorry. So no one who is stronger than me is fighting, but someone who is weaker than me is fighting. Then in that case, if I don't fight, I get killed by the person who is weaker than I am. That's not going to happen, obviously, so I will choose fight. I think that's how you get these sets of conditions, and once you have the best response, I think finding a Nash is about guessing these things. So this, I think solving this is probably impossible, so we always start by guessing something and verify this actually works. So the thing that we should obviously guess is everyone choosing n, which satisfies this, because when this happens, this condition is satisfied. So no one else is fighting, so my best response is to not fight. For all of them, they are symmetric. All of them are choosing the same action, so all of them are best response at the same time. And the other one, we can try everyone is fighting, which is a Nash as well, right? So if everyone is fighting, then it satisfies the condition here. So n minus I is larger than 0. So for one person, it's not, but it will satisfy the condition here, who is the strongest person. So this for this person, this condition is used. For everyone else, this condition is used. Then we get that all of them are best response too. So these two, at least, they are Nash equilibrium.